Guys, welcome back to another video, and today we'll be in this plane. We've done a lot of plane videos. I've done about 8. Like, no joke. I think so. Okay. It's weird because they go up wherever they want pretty much, and they go down wherever they want. It was a minute ago, they're all coming down there, now everyone's going up. Ooh, ooh, feel those rails. Thank you. Oh my.
It's a free one.
Yeah, it's free. Well, I think it's free, but yeah.
That was so unstable, those stairs, George. Oh, it stinks in here. What are these? Dad? What are these? This thing.
For them.
Yeah, I think the sides
So there was, see roughly where that black cable is hanging down, just over there.
Yeah.
From about there back,
Sorry.
there was like a bulkhead with a door in it, similar to.
He's like ugly,
Imagine that.
ugly seats, and it stinks.
The students, my students are taking it.
Yeah, go into the cockpit, guys.
Right, so you're in the
Stinks of bacon and stuff in here now.
Made your way to the galley.
So I've got this roof.
Toilets, no smoking.
Want to come in, gents? There's a seat here. Okay, so basically, you're in the business end of the Vickers VC channel. Okay, so the first thing you notice is quite a fairly spacious cockpit, a lot of room. Captain seat, as convention, is on the left-hand side. Co-pilot seat is on the right-hand side. Behind where I'm sat is the flight engineer's seat. Behind me is the flight engineer's panels, which you'll notice is rather an array of switches, dials, and all sorts of. It's like a sweet shop, right? An awful lot going on here. Now, it is said the flight engineer is probably the most important character on board the flight deck. The captain won't like you saying that at all, but it is simply because the role that he or she performs in the execution of the duties of the flight profile. Directly behind you here is the nav station. Okay, so that's a rear-facing position, and there's a load of navigational gear on that wall. Okay. All right. So above you, we'll start from the top and we'll go down and normally do this. We're missing at the moment. There's IFF. What's the I for? It's friend or foe. What's the identification friend or foe? So this is your transponder stuff. So when you're actually flying, you basically make sure that you are who you say you are, and you're not going to get any sort of foreign forces intercepting you and probably shooting out the bloody sky, all right, which is not very good. Okay. Positional indication here. This is an interesting one, as I explained to the previous guys here. So this basically is indications of the control surfaces. All right. So starting at the glasses on. I should know this off by heart anyway. So on the wing we've got ailerons, right? The ailerons are split in 2 sections. On the top here we've got spoilers. Spoilers, there's three speed brakes which deploy hydraulically on each side. That's actually controlled by this lever here. That is applied basically on landing. But before all that, your pre-flight checks, you just want to make sure that your feedback from your rudder position indicates there's 3 sections of the rudder, and also your wing. Well done, it's got the elevators in, hasn't it? Are working. So if you're not getting any of that positional indicator, you probably think, well, hang on a minute, are they actually working? Well, they probably are. There's probably a signal problem here, but it's kind of important because it gives that extra confidence. The rest of it, all the gubbins around here is things like landing lights, it's a cabin PA, things like that. I won't dwell into all of that detail. So we'll concentrate on what's in front of you directly. right behind the steering yoke, you've got basically your flight instruments here. Okay, so this is fairly standard stuff. They're duplicated on both sides. The obvious one that you can see that's tilted directly at 90 degrees is your what we call our artificial horizon or your HDI. Okay, one up the way, also actually sunk quite a bit. We're actually turned harder starboard, aren't we? We're actually flying pretty much 90 degrees north. Directly below that we've got the compass. Okay, it's actually heading information. At the moment that's saying we're heading north, or we're not. It's because we haven't got the directional gyros running, we haven't got any feeds on that, okay. You've got a vertical speed indicator which is directly, well on this side anyway, that says VSI. That's your vertical speed indicator. So that actually gives you your rate of climb and descent. Okay, so it's not telling you how high you are or whatever, that's actually giving you a clue as to how many feet per minute you're actually climbing or descending. Okay. You've got a Mach indicator, so if you go straight to, well, review, it's here, directly here, review, so it's there, that's your Mach indicator, so it's giving you a clue exactly what speed you're doing. There's some direction finder instruments there. Here, you've basically got your brakes, those are your brake pressure readings as well. So brakes are actually applied on this aircraft, like most aircraft, by the rudder pedals. So the rudder pedals in front, obviously with your feet, if you put your feet on those, that will actually, pushing left and right will move, under power, will move the rudders. But pushing them both together, right, is pretty much almost like brakes on a car. You've actually introduced the brakes, but you need to be sure that you've got enough brake pressure in your system before you depart. Now, if you've flown commercial before and you've been on board there on your way to on holiday, you'll know. Once you've got the push back, you start to move, and then you'll feel the aircraft sort of like basically lurch forward a bit. That's basically a brake test. Okay, and there's a good reason why that happens. Okay. All right, moving down we'll go to the centre. The only indication that you've got actually, the crew have got that the engines are actually operating when you start demanding power from the throttles here. Are these dials at the top, and these are RPM gauges, all right? Now they're actually set in the zero position at the moment. They idle sort of around about sort of 50%, something like that. When you demand power, then you'll notice actually you'll see them move. So I've got the flight engineer actually can control them as well. Okay. So you'll see those increase up to whatever power setting that you want. All right. Immediately below those, you've got a few red lights there, but immediately below you can see those two indicators that say flap and then slat either side. Those are your actual your flat position indicators, and they're controlled by that lever there. So basically lift up and pull those back. Is this interesting, or is it?
Yeah.
Okay. All right. So sometimes I hear people falling asleep. So one of the features of the British Airways the BIC Vickers VC10. Sorry, I'm doing this too long. It's got what's known as a full flying tail. Okay, so the whole tailplane, although it's got elevators at the back, it can actually, it's in its own right, it is a wing form, and that actually can be set out of position at any demand that's required for whatever flight profile that you're in. And the position indicator is this dial here. So I won't go into all the sort of details of it, but effectively it's a trim control, which is actually controlled by these here. All right. So in flights, particularly if you nose up too much, you can actually trim out slightly, and it's just quite easy to do, and you just trim things down. But that indicator will actually give you a visual idea of actually where that flying tail is. Whenever you become seasoned and experienced, you should know, and you should get the feel of actually what that is like. All right. So travelling down, we'll go on to here. So we talked about throttles. Thrust reversers on number 1 and 4. Okay, so if you've been down the back of the airplane and looked underneath, you'll see on the outer engines, towards the rear, you've got underneath you can see, it's the same on top as well, you've got a grille. That grille basically is designed and it's angled at, I think it's something like 30 degrees forward. When these are applied, you actually engage hydraulically some clamshells which actually they're inside the back of the jet pipes, and they effectively close up and they divert the jet, call it efflux to be posh, or the jet thrust outwards. Okay, so that actually gives you some braking capability. Normally applied if necessary, because some runways are so long you don't need to have it. But shorter runways or where there's need to actually brake a little more, maybe a little bit aggressively, let's say, you can engage the thrust reversers down to a certain speed. You can't really be using them all the way to a ground stop, because if you think about it, all the stuff that's being pushed forward, if there's any rubbish, and I'm not talking about fod or bits, tin cans or anything like that, bits of grit, bits of stuff, where's that going to end up? Straight back into the engine, even though the engines are fairly high. Autopilot. Oh, these station boxes. These are basically control your volume and your radio volume settings for your HF, VHF, intercom. This is your autopilot control system. There's two separate autopilots on board this aircraft. Okay. Yaw dampers. Did I talk about yaw dampers? I think I spoke about yaw dampers. Yaw damping is a feature on most big aeroplanes where you don't really want. If you start to yaw, so basically it's in that basically, the nose moving left or right and tail wag. It's not particularly comfortable, certainly for the passengers, but it actually can be quite dangerous because the aircraft, if it starts to yaw too much and it's undemanded, right, you can actually start to roll because it's just a characteristic, and you don't really want to be doing that. So the design, even as long ago as it was, and it's now a modern airline, is actually yaw damping. So the flight crew can carry on flying the aeroplane, and it's automatically any deviations or fluctuations are basically taken out. And there's two yaw damper systems in the standby. Okay, and those are actually engaged with these switches here. Okay, altitude lock, indicated airspeed lock, and also a Mach lock as well. That's not Mach lock in Derbyshire, that's a Mach speed. All right. Coming a bit further down, radios. Okay, trim. We talked about trim for the elevators. This is trim for rudder and trim for ailerons. High pressure cocks. These are basically the behest of the flight engineer. These are the once we start to start the engines up and we want to feed the fuel in, the fuel goes in at a fair old rate. So these high pressure cocks are actually engaged, and as we bring the engines up to up to idle and they're ready, we actually lock them in, and it's all ready to go. So in normal flight, you will see those roll forward, and that's it. Yeah, I think I've basically. Flight engineers, but there's just so much here. It'll take ages to go through it. But basically, fuel control here. I say it's giving you indications of what we've got on the aeroplane. We can also move fuel around. If you've seen anything to do with Concorde and how that got to operate like it did, that was all basically down to actually moving basically fuel around and keeping the centre of gravity where it needed to be a little bit.